Now it's time to deploy and run and access our first application, that is Hello Docker Desktop, and that we are gonna do in a single node cluster. So I'll take a sticky note. So this is our first exercise in Docker in K8 in action. So this is exercise 1. And it is Hello Docker Desktop using Kubernetes. So this tutorial demonstrates how to run a sample app on Kubernetes using Docker Desktop and Kubernetes. So it will create a single, so using Kubernetes extension in Docker Desktop. So here we are gonna create the first step is create a single node cluster. That's a single node K8 cluster, a Kubernetes cluster. Then once it is done, we will write our deployment file. We have to create a deployment. So create a deployment. Then once the deployment has been created, then we will create a service, because without service it's impossible to expose this to the external world. So here when you create a deployment, the pod will be created and replica sets also can be created. And then fourth, access this through internet. And then fifth, clean up. So these are the things, tasks we are gonna do, nothing much. So let's get into the action. So before that, I would like to show you some important aspects. So this is what it consists of. So the first step is to create a single node. If you want to create a single node, you have to get into the Docker Desktop. So this is the Docker Desktops. The prerequisite is Docker Desktop should be installed in your computer. So I hope everybody has Docker Desktop in their computers. So now let me click on settings icon, and here you should see different settings on vertical menu bar. So I'll click on Kubernetes, the fourth one of left vertical menu bar. Yeah, here. So Kubernetes V version 1.25.4, this extension we have. So I'm gonna say enable Kubernetes. So start, when you say enable Kubernetes, what it's gonna do, it will start a Kubernetes single node cluster. You see that it will start Kubernetes single node cluster when starting the Docker Desktop. So but how will it start? Of course, see, when we click here and then say apply and restart, it will start. But how will it start? The question should come in your brain. I'll show you. So let me randomly open git bash. Okay, and pull it here. Yeah, so what I'm gonna do is I'll say cat and tilde and cube and config. See that this is the present kube config file that we have. So let me clear the screen and execute the same, and here is that kube config file. So let me explain it one more time, because without kube config file the kubectl cannot be used. Kubectl cannot access the cluster. So that's the reason I'm saying. So now we have we have a default config file. After the when you install Docker Desktop, this config file will also be installed in your directories. So this consists of API v1 cluster. This is the cluster information. So the cluster till here, yeah, the cluster is https kubernetes docker.com. Okay, this is part of Docker Desktop. So the space, the server, the cluster space, you will get it in the Docker Desktop directories. Okay, and the name of the cluster is Docker Desktop. You see that? Docker Desktop. We are going to get into that later. Okay, the context here you see. So what it's going to do is it's going to marry, or it's going to connect the user with the cluster. So cluster is Docker Desktop. It's a part of Docker Desktop directory, whereas user is me. That's kubecharan. Okay, this is me. So now this context is attaching user with the cluster. So this is properly done. You don't need to do anything else. So, and one more context in this, it's a, here you should see cluster name and user and the name. So current context is Docker Desktop again, no problem at all. Now let's look into the users. So users, we have only one user, that is Docker Desktop. So Docker Desktop is going to use this. So, and this is the client certificate data, and this is the client key data. So I hope you got it. So we have this. So that's the reason we will able to access, we will able to use kubectl. So let me write the prerequisites and then let's get into the action. So prereqs, one is Docker Desktop, 2 is kubectl. Rest all would be fine. You don't need to touch anything. In Windows machine, it's specific to Windows machine. Of course, you can do the same with other machines also. But these are prerequisites, and this is are the steps that we are going to do. Okay, so we have the config file. So obviously we can use kubectl. We can connect with our cluster also. But where is my cluster? So the cluster I am going to create. So I'll say apply and restart. Just now we have seen so config file, as you have a config file, so now it can start the cluster. So let's wait for some time until it starts the cluster. So by the time, what we can do is we will clear the screen and we'll say kubectl, yeah, and help, and these are the some of the commands of kubectl. So out of whichever command that we widely use, that I'm gonna say create, we use widely to create a resource. Basically any resource, any object, we'll use a create directly. And similarly we use apply also for the same. Here is that advanced commands. These are advanced. Create is the old one. Apply, it applies a configuration to a resource by file name or std in. So patch and diff and customize, and we have create, expose, run, and logs. You see that logs exec and describe, it show details of a specific resource, group of resources. So it's taking more time, but you could see that Kubernetes is starting. And tooltip, when you hover over to this icon, Kubernetes icon, so it is, the tooltip is projecting outwards and it's saying Kubernetes starting. Let's wait for some time. It's gonna start. Until that, let's wait for that. Here you could see Kubernetes running now. and it's up and running. You can see that green color. So enable Kubernetes. So now we should able to see our cluster, because when it starts, Kubernetes single node cluster will be started. So to see that, what we are going to do is we will open a Windows PowerShell and we'll run it as an administrator and save as, clear the screen, and of course it's been configured. We have a config file properly, so the kubectl config file consists of a Docker desktop user and Docker desktop cluster, so no issue at all, so we can easily use it. So kubectl get node, you see that it's a Docker desktop, the node name is Docker desktop, and then status is ready, and then role, of course we have, it's a single node, it's a control plane as well as the, so both it will do all. So version 1.25.4. so now let me check. So we have our cluster that's up and running, so no issue at all. kubectl get node, so we have our cluster up and running. That means in sticky note, the first part, creating a single node cluster, has been done. So now the second activity to be done is to create our first deployment. So a Kubernetes pod, a pod is a group of one or more containers tied together for the purposes of administration and networking. So the pod in this tutorial has only one container, like this. I'll show you that. So like this is our working node. Let's consider this as a Docker desktop working node, and then we do not have all other pods at this moment. We have only one pod, and inside that we have only one container. So let me get here now. So a Kubernetes deployment, it is one object. A Kubernetes deployment, what it will do is it checks on the health of your pod and restarts the pod's container if it terminates. So deployments are the recommended way to manage the creation and scaling of pods. See, in spite of direct, you can create a pod object, you can create a replica object, but in spite of directly going for the pod object, if you use a deploy object to create your pod, so the more benefits or more features you can get. It's like you can scale it up using replica set, and you can manage them, you can upgrade them, you can do whatever you want. So that's the reason, even here also I'm going with deployment only. So what I'm gonna say is kubectl create deployment. So let me clear the screen. I'm gonna say kubectl create deployment is and the name I'm gonna give for this is hello is fine, and hello Docker or hello Docker desktop, because this is what the hello Docker desktop, hello dd node. Okay, that's what the name. And then the image, I have to get it. So image, I will get it from the registry dot k8s dot io /e2e, and it's a test image. Basically these are the test images specifically made for the learning purposes, and /. and name of the image is AGN host. Its version is 2.39, and give a space option and / AGN host, and it's netexec, and the host port HTTP port. I'm gonna go with this HTTP port 8080. That's it, and let me click. So our deployment.apps, so hello DD node has been created. So the name of the deployment object is DD node. So here you could see that deployment.apps, and here you can see that. Now what I'm going to do is I want to view the deployment. To view the deployment, I will say kubectl get either deploy or deployments, whichever is fine. So we have a hello node. This is old one, 91 minutes ago. So here we have created just now 31 seconds ago. The age is just 31 seconds just now. It's hello DD node. It's DD node. So now it's clear. So it's ready. No problem with the deployment. That means it might have, this is deployment object. This is not pod. This is not pod object. This is deployment object. When you deploy it using deployment object, the pod will also be created. So we will look into the pod now. But you can see that it's ready and up to date, and it's available. Desired state and then current state. So everything is done. Now let's view the pod, because pod is part of the deployment. So now I'm gonna say kubectl get pods or pod, whichever is defined. So here you should see the pod name is hello DD node, and then some random characters and random numbers, and then this. Okay, this is the name of the pod. You can see 102 seconds restarts. We haven't restarted it again. So at this, the status is running. It's ready. No problem with our pod also. So it's a single container pod. You can see that on the screen. This is our Docker desktop node. Let me put all together. Let me put all together. kubectl get node. This is a Docker desktop node. Here it is, control plane. And then kubectl get deploy. And this is hello DD node. So this is our deploy object. This is a deploy object. Now let's see the kubectl get pod, and this is our pod. You see that? You can see on the screen, this is our Docker desktop node, and this is our pod. Okay, now let's also see kubectl get events. A lot of events are there. So basically scale up replica set hello node. So replica set is also mentioned. If one has been deleted, other one will be created automatically. So let me clear the screen first, and if you want to describe that, you can do that. kubectl either deployment, or let's do that for the deployment. kubectl get deploy and hello DD node. kubectl get describe its deployment, and it's hello DD node. And this is, so it's normal scaling replica set. And so how many? It's one, just one. Let's scroll up and we should able to see more information. Host port, image, you got the image. Okay, and port, host port, nothing. And environment variables, mounts, volumes, nothing, completely empty. Other than the HTTP port is 8080. Rest all fine, so nothing much to replicas. One desired, one updates, and one total, one available. So selector app hello DD node. So rest all it's fine. There is nothing much to view here. Okay, all done. Now it's time to expose. Okay, let's get into this. Create deployment is done. Now it's time to create a service. But why do you need to create a service? That's my question. See, when you're working on the Kubernetes, just randomly finding code and then executing that code, no, it doesn't work that way. You have to understand why you're doing that. Why do we need to create a service now? You tell me. Tell me first. By default, the pod is only accessible by its internal IP address within the Kubernetes cluster. To make the hello node, here this is hello DD node, that's a deployment container accessible from outside the Kubernetes virtual network. You have to expose the pod as a Kubernetes. That's the reason we are creating a service objects. There are a lot of objects in Kubernetes. Every object has a specific meaning, specific functionality. You should know that functionality very well when you are working on the project. So why do we create a service? All files will, all definition files of object look similar. It doesn't mean they are same. You should understand their purpose and functionality. That's the reason in my Kubernetes part I have clearly explained each and every object separately, and we have done 2 to 3 examples for each and every object separately. So now let's get into the action here. Enough of daunting. So let's create a service so that I can expose this application to the external world, probably to you. So I'm gonna say kubectl expose, and how it is deployment, and what's the name of the deployment? Deployment. So it's on top, but I remember that it's hello DD node. That's the name of the deployment. And what type of service I want to use? We have seen 3 types of services: node, port, cluster IP, and load balancer. I always prefer load balancer. Here I am going to use load balancer only. So type is equal to load balancer and port 8080. That's it. So the type load balancer flag here indicates that you want to expose your service outside of the cluster. The application code inside the image, that is only listens to this port 8080. So if you used kubectl expose to expose a different port, clients could not connect to the other port. So that's the reason you have to give the default port only, that's 8080. So let me click enter. So service, and then the name of the service, hello DD node has been exposed. Let me view the services first. kubectl get svc, that's fine. And you see load balancers, we have 3. One is Kubernetes. This is a cluster IP. Okay, it's a fundamental, it's a default one. And hello node, this is old one, it's 97 minutes ago. And we have hello DD node. You see that DD node, Docker desktop node. And then a load balancer, and external IP is still pending. If it is not, if it is still pending, means our we cannot expose our app. So cluster IP is this, port is this, but it should be. let me rerun it and see. Let's see now. It's still pending. What I'll do is I will delete this because both here only one local host we have, right? So let me delete this. So kubectl and delete svc hello node. So service hello node has been deleted. Now let me cross check kubectl get svc. That's it. The load balancer has been the local host external IP has been allocated to the load balancer. Now we should able to access this at 8080 port and then local host IP. Let's see what's gonna happen. Get into the browser and click local host, yeah, and 8080, that's what we want, and click enter. That's it, successfully deployed. And you see that now the time is so this the date and then time and UTC also. So let me refresh it. Changed. Let me wait for a few more seconds and refresh it. Change 15 seconds, 17, 18, 19, 20, 21, 22. So that means my app is up and running. You see that? So we have deployed. When we are deploying that, we have dealt with both a replica set object as well as the pod object. Once the pod is up and running, then we have created a service we have exposed the deployment to the load balancer service. And then here it is. Here we should be able to expose that application outside the cluster. So now let's say kubectl get services. That's the other way of getting the services, and similarly you'll get the same response. And then external IP is the local host. So that's it. Let's clear that everything whatever we have created so far. So we will remove all those things. So now if you want to see all, we can say, let's before cleanup we will say kubectl get all, and you can see all deployments. We have hello dd node and hello node, two deployments we have. All two deployments are shown. And then we have two services, default cluster IP service and then load balancer service. And then here you should see pods, okay, replica set. These are replica sets, basically replica sets. That's what I'm saying. This is the fun of this thing with deployment. Okay, with deployment we are able to see kubectl get. You got the pods information, you got the service information, you got the deployment information, you got the replica set information. See this a replica set we haven't created, pod we haven't created directly. These were all created by the deployment only. When you deploy, so by whatever, if the whatever things that you have mentioned in that file regarding the pod and then a replica set, all will be executed. And you should see the pod as well as a replica set as well as deployment. And then finally we have exposed this to the outside the cluster using load balancer service. So here in front of our eyes we are able to see four objects: replica set object, deployment object, service object, pod object. I think it's pretty clear now. So now I'm gonna clean up. So kubectl delete service, it's hello dd node. That's it. The service has been deleted. If you want to cross check, you can cross check, but let me delete deployment also, and then delete. No. Okay, I deleted only service. That's fine. So, but what I want to show is I forgot actually. So I will. So we have created a service accessed through the internet, and then before cleaning up, I want to do one more thing. I want you show the container. Show the container which is running inside my pod, inside my Docker desktop node or working node, not working node. Okay, so let me show this, but before that let me run yeah, let me create the service again. Yeah, now we got the Docker get svc and use. No, oh sorry, not Docker, it's kubectl. Yeah, here, hello dd node. So now let me show the image first. See, this is how a working node, and then inside you will have a pod, and inside the pod you will have a container. So that's what the representation. Now I'm gonna show it live. Brace yourself for the fun, huh? I'll show it live. I'm going to the Docker desktop. So here, to see the containers which are inside the pod, we need to check this one. That's a show system containers. This is a pretty advanced one. When you check this, it will show Kubernetes internal containers when using Docker commands. So now I'm going to say apply and restart. Let's wait for. Yeah, so I think it's got applied. So now let me get into the Docker space. You see that? So these are images. I'll show you image one by one. The first one is Kube API server. Did you remember this Kube API server, which will be there inside the master node? And then you see that Kube proxy, which will be inside the working node. Kube controller manager, part of master node. Kube scheduler, part of master node. Kube etcd, part of master node, and pause and some other information, some other images which are belongs to that. Now let me get into the container, and I'm gonna say, so Kate's pod hello node. This is hello node. This is previous one. I want hello dd node. Here it is. You see that? Hello dd node. What I'm showing it to you is a container which is inside this pod. I'm showing it to you. Is it? I hope I should. I think you should get more excited now because you're seeing a container inside the pod, which is not normally possible. I'm showing it to you now. So this is what is the container pod. See, K8 pod. You see the name? It's a K8 pod. Inside that pod, you have a hello node, and this is that, and it's running. So now let me say view details, and this is K8 pod. Inspect terminal status. Okay, and let's get back to the containers, and K8. Yeah, this is our pod, and this is the container which is running inside the pod. Now hello dd node, you should see that hello dd node. Both were created just 18 minutes ago. I'm gonna view details and see the logs, because that's the container which is running inside. So now I've shown pod, working node, and container which runs inside that also. So these are the container logs. So what had happened initially, it started HTTP server on port 8080, then on port 8081, that's UDP. Let me go to the inspect. In inspect, you will find all this information. Hello node port and Kubernetes port, a lot of environment variable you should find out here. Okay, path and ports bounded, and etc host mount points also. You could see that. So now let's get into the terminal. As usual, the terminal, it's similar to that. Let me say ls and pwd, present working directory is root virtual directory, and when I say ls lrt, and you should see all the directories: tmp, var, srv, opt, mnt, media, home, localhost, lib, bin, usr, sbin, sys, etc, everything. So, and you can also check the statistics. It's a 9.1 MB memory usage. So now let me get back to that. So here we have seen a working node, a pod, and a container which is inside that. So this is a pod. That's a pod hello node. Let me get the pod name also. kubectl get pod, and this is what? Correct, hello node 24 sln, and you see that 24 sln. This is the pod k8 pod hello node 24 sln. You got it? So this is our pod. You are able to see our pod also. So now you can start and stop the pod from here. You can restart the pod from here. And similarly, this is our container. You can start and stop the container from here also. Okay, so let me restart the container, restart the pod from here. The pod has been restarted. It's just 0 seconds, and the container I will also restart. So let me get into the, and let me say, and here is that pod, yeah, running. That's it. So this is how we can see our pods, and with this we have demonstrated this also. So now let's clean everything. So it's time to clean up. We have seen too much. It's time to clean up. So kubectl delete svc, okay, I'll mention service directly, and hello dd node, then kubectl delete deployment hello dd node. That's it, and the pod automatically will get deleted. That's a kubectl get pod. Yes, it's gone. You got a hello node, a normal one. So let me delete all those things also. Cube delete. So service, so no service such deployment. Let me check. So deployment has been deleted. So now we should not have any pods now anymore. So let me say kubectl get pod. So no resources found in default namespace. So now let me get here. So you should see images, those were copied, so they will be there in local machine. Whereas let's come to the container. So dd node, these are in exited state. You see that they are also going away. Okay, now only this hello node has been left. I think this is pod, hello pod, that also should go away na, because rest all gone. So kubectl get pod, I think kubectl deployment, it's deleted. Okay, no resources found in default namespace. This should also be deleted. Okay, what's wrong? Let me show. Yeah, okay, it's not getting deleted, but it's an exited state. It's gone. So let me delete it manually. So that's it, cleaned up. So we have seen pods, we have seen working node or node, and we have seen a container inside the pod. visually, we have experienced it, all those things. Till now these are all abstract things, they are somewhere else. We have never gone, we have never gotten the concrete feel of looking into the container pod. So now I have shown it, I have shown that also. So now let's meet in a second exercise of Kubernetes.